So today we'll be looking at linear programming. That is the entire section of videos, but we'll be looking at some general introduction and try to have a general understanding of the topic. So let's try and understand this as a web or a map diagram so we can map our concepts together. So first we try and understand what is linear programming or LPP as it is abbreviated in short. So we'll go over this topic and then look at some specific concepts. LPP is basically the process of minimizing or maximizing a linear objective function subject to a finite number of linear equality and inequality constraints. So that means there'll be some maximize or minimization problem. We need to optimize it, and the optimization will be subject to some real world constraints, and we will have to use these constraints in order to find a more suitable value. So, some of the places, obviously, if we're learning this concept, it must mean that it has some application in the real world. So, where and all are LPP used in the real world? It has like a major application in the airline industry in terms of scheduling, like when should this flight begin, so that it reaches it at this time and so on. So we use a lot of linear constraints there. Second is general industrial and in the industrial and processing and manufacturing areas. So in order to we need to produce these many units of some product subject to some constraints, like this a person cannot factory cannot spend more than this much money and so on. And third is in networking and communication. So in terms of routers and stuff, we can understand where a certain message should start and where should it end subject to what constraints and so on. So LPP is usually involves a problem with n variables, which we can represent as from x1 x2 so on up till xn. And these n variables we will be writing in those constraints that we already mentioned. So we can formally define a linear objective function. There are some things that LPP must have, and one is a linear objective function which must be minimized or maximized. So it is represented as maximize or minimize of c1 x1 plus c2 x2 plus so on till cn xn, where x1 x2 so on till xn are the n variables we spoke of, and c1 to cn are the coefficients in the objective function. And the other thing that any linear programming problem must have is a set of m linear constraints, which we spoke of. So the constraints are that which the problem is subject to, and it is generally represented as ai x1, ai x2, a1, a2, x2, so on till an xn, and is less than or equal to some constant b, or greater than or equal to. So basically a set of variables x1 till xn with some coefficients less than or equal to some value. So one of the terms we need to understand with respect to LPP is what a feasible set is. So these are some major terms relevant to LPP, but further these will be used in problems which we'll demonstrate later. So feasible set. Before we talk about that, let's understand uh, how we represent linear programming on a graph. So linear inequality basically divides some n-dimensional space. In terms of a graph, we're taking a 2D space here. It divides it into two half spaces, one where the inequality is satisfied and one where it is not. So where whichever side of the line that represents the inequality is what our problem needs, we consider that half space and we reject the other half space. This is the fundamental of any constraint and how we represent it in terms of a line, which is an inequality in a graph. So feasible set is a solution to a family of many such linear inequalities. So a problem won't have one, it will have many such inequalities, and we need to find what is feasible for all. The linear cost functions defines a family of parallel hyperplanes, which basically lines in 2D, or if it's 3D, then they're planes, and we should find one of minimum cost. So what we do in cases of many such lines is we try to understand and locate the corner of the feasible set. So in terms of this graph that we are drawing, if let's say we have those two lines that represent two inequalities, that portion enclosed by the graph and that represents our feasible set. So the points that we must consider are the 4 points, 4 corner points of this region. They are called corner points because they form the corner of the polygon. and these corner points obviously will be represented by some coordinates in space. We can take them as a1 b1, a2 b2, a3 b3, and a4 b4. Further, we'll be understanding the value, finding the value of the function at each of these corner points, and try to optimize by finding the minimum or maximum value. Now we'll understand with the sample minimization problem. We have to minimize z is equal to 10x, 20x plus 10y subject to some constraints. The first thing we need to do is list out all our constraints one by one.